This is where you can see that the agents have the sequential placement. So one agent can transfer data to another agent, and policy name exists within the query. Then just assign the policy name over here. So this is everything about how you can build LLM agents while using Google's ADK. What's up everybody, welcome back to another video within the Generative AI tool series, and in this video we'll continue to talk about building agents using Google's ADK. So if you just landed onto this video, I strongly recommend that you go and watch the previous part of this video where we build a basic form of a policy agent using ADK. We walk through some of the steps that this agent development kit actually provides you, and some of the concepts that how it actually works, how you actually make sure that the agent works. So yeah, so I'm gonna hook the video up into the cards, and in this video we will be evolving that particular agent and we would be adding some more juice to it. So let's talk about it. So we were on the agents page, and just a one-liner: an agent is a self-contained execution unit designed to act autonomously to achieve a specific goal. No biggie, we already know that. But the thing that is important and something that I want you guys to pay attention is what ADK actually offers you in terms of agents, of course. So this particular diagram is everything. So what we built was a base agent, right? And it was a base class of agents. So what you see below are more specialized and primary agent types that Google's ADK actually provides you. And the very first one is something that we're going to build. And the following ones, like workflow agent and custom logic, is something that we'll explore in the upcoming videos. So if you see, you have an LLM agent, reasoning tools and transfer, and then we have workflow agent, which is more like sequential, parallel, loop, and then we have custom. To really understand it, I have a diagram. So the agentic framework in general is a broader term. But what Google ADK adopts is, it adopts all these agents that you see, or all these patterns. So what you see on the screen right now are more like design patterns, but for agents. So for example, you have network or horizontal. So this is where the agents can interact with each other. We can achieve it through Google's ADK as well, and we're going to talk about that as well. So then we have hierarchical or vertical. So here your agent can has a spread like a binary search tree, and it can sort of vertically divide its task. So the subtypes of network or horizontal is sequential and loop. So this is where you can see that the agents have the sequential placement. So one agent can transfer data to another agent. So just like it's like consider two particular API routes, and if you're receiving a particular API call in one route, you can always route or transfer control to another function or to even another route. So again, I want you guys to sort of process it, because yes, the future is like you can leverage agents in terms of replacing routing as well. And we'll explore this while exploring Google ADK as well. Then you have this loop feature where if you have a certain placement or a certain logic where you want the predecessor agent after a successor agent, or in a loop, you can build that logic. So it's specified as self-healing. So for the second section, which is the vertical section, obviously you can distribute tasks. Just like you have a particular task and you can spread it into threads. The very same concept applies over here, that you can spread your task in parallel. You can hand over your task to two parallel agents. So these are the three, settings or placement that we're going to explore while learning Google's ADK. All right, so we are back within our code. And again, just like I mentioned, this is more like an evolution of our previous script, previously we were using agents.py, and this is where we actually explored the whole workflow. We talked about what runner instance is. We talked about how we can use, run conversation to call our agents asynchronously. We talked about session and their capability of storing users' history, users' chat messages. We talked about how we can build a baseline agent. We talked about different variables that are dependent on it and some helper methods. So in this particular video, we'll be talking about LLM agents. So let me just collapse it. Same stuff as Syncio, data classes field. We'll talk about why we needed OS uh, for file system and stuff, possibly to access the .env file, the generative AI toolkit, and we're sort of pulling in the Gen AI instance, which helps us to hook our Gemini API key, and it also hooks with ADK perfectly. So if we instantiate our Gemini API key over here, we can easily use ADK without any explicit API key, passing the API key through it. Then we are importing a few set of types, and this time we're not importing agent. Instead, we're importing LLM agent. And since we need to hook up the memory and stuff, so I'm using in memory session service runner. We have already seen it just in the previous script, and we're using Pydantic, which is kind of interesting why we need it. All right, so again, standard stuff here, just pulling in the Google's API key and setting it within the Gen AI object. All right, so before I talk about policy output data and policy input data, let me scroll a bit. Let me squash this as well. Let me squash this as well. All right. So again, I'm defining my application over here, app name, user ID, session ID, agent model name, and we're using Gemini 2.0 Flash. So this time, while building agents, I'm not using the base class, I'm using the specialized class because it comes up with, different kind of, shenanigans of its own. So let's talk about them a bit. So I've modified the instructions a bit just to cater a few things, just minor tweaks, nothing major. And I'm hooking up the tool, and this is where the action happens. Get policy information, and now I have some set of shenanigans, and I'm gonna talk about them one by one. Before, let me scroll down and just to explain the rest of the script so that we can just jump onto the important stuff later. So this snippet here, also, I didn't mention in the start of the video, I'll make this available within the description of this video. You can find your GitHub gist and you can replicate it, test it. Obviously, you'll need your own API key, but you will have the code. Don't worry about it. So I'm creating my session over here by providing it the app name, user ID, session ID, and then I'm instantiating the runner, which actually orchestrates or runs the whole agent and manages the workflow. So I'm passing my policy agent over here and passing my session. And then I'm using a run conversation method where I would just, call my agent. And we'll walk through this particular method. So I'm just asking two questions, and you can see that the difference between two questions are, pretty specific. So what is the remote work policy? But in the second method, interestingly, I'm passing in the JSON, and I'm just saying policy name, remote work policy. So I want to demonstrate something, obviously. So going back to my agent, okay. So here, now you might be, you know, now you might be speculating that, okay, that's why the JSON. So LLM agent really helps you to, really gives you the leverage where you can control what goes in and how it goes in terms of the format of, the arguments. So imagine you have multiple agents. So for this particular diagram that I showed you right here, now just imagine you have multiple agents. You cannot just solely rely on text. For example, one agent passing textual information to another agent. Obviously, at certain point, you would need structure for all of these agents to work, like a unit. You would need some structure. How can you attain that structure? Yes, thank you. You can attain that structure by limiting the input schema, what goes into an agent, and output schema, what goes out of the agent. So when you make sure that these two things are in check, then you can have sophisticated and collaborative agents. So in this particular example, I'm hooking in my policy input data, which is made out of Pydantic models. So I'm just adding a policy name. All I'm interested is just to pass a policy in a specific way. And that's it, just to keep things simple. For the policy output data, I'll talk about it because it has some precondition which sort of affects the way the agent performs. So when I do this, I'm actually making sure uh, you know that a structure is imposed in some way. But the thing about LLM agent is that you can give away, and it's kind of confusing, so I would like you guys to pay attention over here. You can state that your input schema can be in a certain manner, which we're doing right here, but you cannot impose it, which means that this particular agent would always have a fallback option in terms of text. So if you pass in a text like I'm doing, what is the remote work policy? And since it would see that it's not JSON, it would still continue to answer it. But if it finds out that yes, there is a structure to it, great. You get to add some sort of validations, or you get to add some validations in terms of, checking error and whatnot. But that's the only catch. And you'd be like, hey, then why just why do we have this parameter input schema if it doesn't really work? Let me explain. So in this particular case, I have imposed a structure indirectly since it doesn't offer it directly. But eventually it will, because these agents will continue to evolve. And just like we add a certain validations to our API calls whenever we post something. So for example, you're posting some sort of data to a particular API route, obviously it would go through some sort of validation, and eventually these things would evolve. But I strongly feel that yes, eventually the CRUD structure would be replaced by agents, and they would be handling all the inputs and stuff. They would be making sense of everything. So here, whenever I call the agent, so I'm sort of printing the query itself, and I'll demonstrate that in a while. So here I'm imposing that check. So if is instance of query, and I have, so is instance is like the query is an instance of a dictionary, and policy name exists within the query, then just assign the policy name over here. Otherwise, just throw an error that hey, this format is uh, we don't accept this format. So what will happen? This thing over here will fail, and this thing will pass. So let's go ahead. Let me demonstrate it to you. I already ran it, but just to do it from scratch and just to show you that this whole validation thing is working. Okay, so here you see what is the remote work policy. So okay, oops, let me expand it a bit and let me scroll this up. Okay, so here it says invalid input. Please provide a policy name as a string or in a dictionary with a key name, policy name. But for the one where I specified JSON, it picks up the policy perfectly, and then it calls a tool, which is get policy information. This is the tool over here, and this is where all my dummy policies exist. requests. So when it states that, okay, I'm searching for, remote work policy, so it's going to match this dummy database, and it's going to pick one and return it to me. If it doesn't find any, it would return me an error. Simple stuff, no biggie. And then the agent responds that, hey, remote work is allowed for approved position. Employees must have a dedicated workplace, blah, 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 blah. So this is the whole thing works. And just to make sure that uh, you guys have, since I hope it's clear now, like how these two particular functions sort of work together in terms of calling agent, and in terms of really representing the response of the agent. Coming back, just like input schema, I have output schema as well. But for now, for this version of agent, you cannot transfer control if you're going for this particular option. And this is something that's been stated in their uh, documentation. And let me show it to you. Tools and output schema. Here you go. Constraint: using output schema enables control generation within the LLM, but disables the agent's ability to use tools. So if I specify this, I can use this. And even if I run the whole thing, for example, if I just control, oh, sorry, control S, save it, and if I run this, I'm going to get an error. There you go. And the error is, if output schema is set, tools must be empty. So that's one constraint. But I'm like, why would I use this within a swarm of agents? Like if I have an army of agents, obviously I need a certain form of input schema, and I need a certain form of output schema as well. And I also need tools. So I again believe that there's room for evolution in this particular uh, use case. So yeah, just wanted you guys to know about this particular constraint. And this one's interesting. Include contents, which is set to default, and this just refers to that. Do you want to include the history, since the history is being maintained within the in-memory session service? So do you really want to add this? So I've said yes. Okay, I'll just use it by default. All right. So if you're coming from the LLM background or generative AI background, you would know what this represents. This is how you make sure you keep your LLM into check. So this here is generate content config, and you can set temperature, which is more like tackles the randomness of the generation itself. Max output tokens if you want to limit. I've currently limited it to 200 characters because that's what I think. Most of my answers regarding what a policy represents are just like 100 or 150 tokens, but I've set a hard limit to it. Top K handles the randomness, top P handles diversity in terms of probability. So the most probable, so if for example I've set it to 0.9, which just means if a particular chunk of words have a higher probability, which is around 90%, then just select that particular pool. And top K is more like how many, if you have a certain limit of words, then choose in between the top K, which are like the top 50. So that's the whole thing. So yeah, I think these are like the major differences that you can see within the baseline agent and a baseline LLM agent. So this is everything about how you can build LLM agents while using Google's ADK. So I hope you liked this video. I hope you learned something new. I hope this was able to clear some concepts So yeah, if you haven't subscribed, subscribe. And we're still going to be talking about Google's ADK in the upcoming videos because I want to build this as a separate playlist. So yeah, don't forget to watch the next video and thank you for watching this one. See you.